for example, when we're going to have some physical network implementation, including 2G launch or 3G or 4G, doesn't matter in fact the technologies, but they are in the physical part. Then between 2010 and 2020, let's see, we can see in the telco part some virtualization implementation of the functions. And nowadays, I mean, starting I think for 2 years, we are trying to follow in the telecom industry, they say, the IT approach with the cloud native networks, and following the path to 2030, why not to think about some autonomous network in the telecom part, and we're gonna see what this autonomous network means. So, how telco in fact evolved? As I said, telco 1.0, the physical networks. This means physical box with physical equipments doing a lot of things. Then they have been evolved to telco 2.0, that means virtualized network. What I have in the physical box, somehow it has been moved, it has been translated into a virtualized network function that of course need support for virtualization. Telco 3.0, that means cloud native networks. It's about containerized applications, the CNFs, network applications that should run in a highly and scalable and resilient environment. And starting from now on, this should be the steps, the way of doing the things also in the telecom part. And ending with the Telco 4.0, with those autonomous network implementation. And of course, as in many other domains, and we see on all the presentation, data, AI, and machine learning, also in the telecom part, we should see this data AI-driven automation for network functions, for network running, network optimization, self-healing, and so on. So this will be the path of evolution, but the focus should be for nowadays in Telco 3.0, the cloud-native networks. So, what is this cloud native for us? And that's why I've said we have an approach and we have a proposal of implementation. This cloud native for us should be the first option to implement the network. The cloud native brings a lot of benefits. So having in mind this open network and programmable support for the network cloud should support us to transform the telecom company into the technical tech cost company within the next year. We support, as I've said, cloud native functions, autonomous network for cloud deployments, powered by machine learning, powered by AI. Of course, at this moment, this cloud native for telecom, having in mind all the requirements of the telecom industry, and that's why I've asked how many of us we are familiar with this requirement, should be in some ways limited in terms of maturity. So, how it could this look like in a telco cloud environment? In Orange, Romania, they say telco cloud environment as a solution that has network management, automation, network orchestration, and so on. And somehow to solve all the requirements, to interconnect to the physical world, to serve the virtual network function or the application, the telecom application, and not only the telecom application in virtual machines, and the evolution to the telco cloud in some specific environment, like as cluster as a service or container as a service environment, having in mind some of these capabilities. And in this conference, I think we are all aware of orchestration, we are all aware of Kubernetes, and so on. But having in mind the way to do the things and to implement the things, not only to bring up and to manage and orchestrate a Kubernetes cluster, but to do this in order to run network functions, containerized network functions, or other network function that in the end brings the services of the operator to the client. And starting from this point, and having in mind those initiatives from cloud for automation, for CI/CD, and so on, also such approaches somehow support the European sovereignty. Because as I've seen also during this keynote speech and workshops, we're talking about a lot of Amazon, we're talking about a lot of Google or Microsoft Azure, but we are not talking about some cloud implementation done here locally in Europe. So this approach also can support, and we're going to see how and why, the European sovereignty in the cloud and cloud native approach through different initiatives that in the end, based on that, should be open source project, open source initiatives, and this is reflective of course in the cost. And we can discuss about the Silva project, and we can discuss about the Nefio, we can discuss about Clay native telecom initiatives, and Camara and Camara API. So there are some frameworks already started, and of course we're going to stay focused in the today presentation on one of them, that is Silva, and you're going to see what this Silva is bringing. Because we are discussing about transformation, and we are discussing about evolution, in that Telco 4.0, but also it starts the journey with the cloud native implementation. We can discuss about the telco transformation to a software-based solution, and this brings the autonomous network. What means this autonomous network? In one moment in time, I hope, we will not need tens and tens of engineers running different, let's say, activities, scripts, monitoring, and so on, to do and to understand what are the issues in the network, but this should be done in an automatic and in an autonomous way. How? We're gonna see, but there are phases and there are steps to do this. As a conclusion, in general, in telco part, today, as you can see on this diagram, within this graph, we are around 2. So we have some partial autonomous network, but the focus after 2030 should be to have a fully autonomous network that should be self-scalable, self-automated, self-monitored, self-healing, and self-reporting, with the support of course, machine learning and the well-known mentioned artificial intelligence framework. But this I think is not enough. In this cloud native environment, we should start from somewhere. And this is an initiative of Orange Romania to implement in this very high complex environment. This is a picture of one of our core network function. A single core network function, in fact, is implemented like that. And we are thinking about a way, based on the data that we are collecting from the entire infrastructure, physical, logical, CNFs, Kubernetes cluster, and so on, to implement a solution that will, in the end, automatically detect issues, errors, will correlate all these issues, errors, and will identify, in the end, the root cause based on some analysis. We have process engines, we have machine learning, we are training the algorithms, and through some mechanism to send to an operator, let's say like that, identify issues of the root cause, and maybe to predict also, or to suggest some way of enhancement. So we have this in mind. I mean, it's already started, and I think for the next year, if we will be here, we'll present the results of this initiative. From my perspective, this will help a lot as a telco operator transformation, including the cloud native part, because we are taking benefits of this cloud native part. These initiatives should really support the network management, should really support the improvement of the operation, and should really decrease the operational cost through software, through transformation, and through automation. So we need to address all this stuff, and we consider that this address could be only done through this cloud native solution, or through this cloud native implementation. We can imagine a solution as a cloud native environment. Could be like a container as a service solution with using different tools and using different software tools. that put it together can create the environment, starting from the existing implementation, let's say, to the future ways of doing the things in the telecom part, and not only. That is in the end the transformation to the cloud native. So starting from this, we can present a solution, a telco cloud implementation solution that can support all these things. So I ask Mihai to continue. You have the floor.
Thank you. Okay, so thank you, Marius, for introducing Silva for us a bit. So what is actually Silva and what is the context that we're actually trying to get into here? As Marius said, there are a lot of, I don't know, difficult points in telco that need to be addressed for the entire lifecycle management. That would be one. The other one would be actually having to fight a bit with the vendor lock-in for each kind of Kubernetes distribution. For example, Nokia might come with a certain Kubernetes distribution that it wants you to use. Ericsson might want to do that as well. And what happens at some point is that you kind of end up reinventing the wheel and having different types of lifecycle management tools and scripts and whatever it is to try to automate this for like a plethora of Kubernetes clusters that in the end basically offer you the same service, just spin up pods. So what's the point of Silva, aside from releasing a cloud software that is tailored for basically for telco requirements and edge? We're trying to come up with supporting some telco features like SRIOV, DPDK, specific network functions, bare metal operations, the sort of delicate security aspect of telecom networking solutions. And another very important thing that we see in Silva is to keep the project open source and allow everyone to contribute to this. So I think we can skip a bit over this because I've just covered it. One good mention here, it would be that we're trying to be infrastructure agnostic about it. So what Silva offers you is, as a CaaS, is not a container as a service, but a cluster as a service. It's an option for you to deploy multiple Kubernetes clusters, basically for each sort of CNF vendors that might need. And we're trying to be agnostic in the sense that you can use VMware as your infrastructure, you can use bare metal or OpenStack, or it's in the works right now to support different public clouds such as Amazon, Azure, and so on. Now, a bit on Kubernetes. So Kubernetes is indeed a very powerful tool. It gets us, I don't know, away from some tough situations with some very easy, I don't know, YAML configuration. You just deploy it. You don't need to learn 10,000 new tools or anything like that. However, it has a few issues when you're talking about big deployments, something like parallel loops, reconciliations, racing conditions, and it's a bit hard sometimes to debug and to replicate what happened in one environment into another, especially if you have different Kubernetes providers for this. So the solution that we found here was Flux. Some of you might be familiar with it. So for us, Flux and its specific spec that depends on offers us a way to some more structured GitOps, let's say, because it helps us tackle some issues that we've been having. So basically, it's an explicit way with Flux to orchestrate and deploy all your workloads on different platforms. Maybe you have readable customization graphs. This one here is not the best, not the best quality of it. But the point is that for a single resource, for the cluster resource, you just have like 20 or 30 Kubernetes resource behind it. So do this for like, I don't know, 30 software pieces that you want to deploy, and you end up with hundreds of Kubernetes resources. And some of them are very intertwined, have a lot of interdependencies. You cannot spin up something like Grafana, let's say, until cert manager has issued its certificate for it, and you have to make sure that one doesn't start up before the other, and so on. You need all your deployments to be reproducible. You need to be able to test, and you need to be able to see those issues that popped up in, I don't know, in a rogue deployment somewhere, and to be able to see it again and to intervene over it. And you need to keep basically Git as the source of truth for now. I'm saying for now just because there was that talk at the keynotes where we did Gitless GitOps, so we don't know. So how do we actually spin all these clusters, and how do we actually do everything? And aside from Flux, it's cluster API at the core of Silva. So I don't know if is anyone familiar with cluster API in the room, except my colleague who's working with me. Okay. So basically what cluster API allows you to do is to spin up these clusters. You have different providers that you just sort of plug and play depending on your infrastructure provider. So be that, as I said, OpenStack or bare metal or anything, you have a provider for it. You just take what you need and you use that. So this is nice because you don't need multiple tools. You just have cluster APIs regardless of your infrastructure. You don't need to have, I don't know, Ansible playbooks for when you're deploying on OpenStack VMs. You don't need to have, I don't know, Crossplane or something like that for when you're deploying into some sort of cloud system or a public cloud. So you just have cluster API, you have Flux, and then everything else is just basically YAML configuration that we're love to hate to love it. Just take your pick. So what is actually Silva? It's actually a big Helm chart, to be honest, that it comes packed with a lot of things, a lot of customizations behind the screen, but makes it very, very abstract for the user to basically go on and deploy its own workload cluster for, let's say, in our solution with the Telco, for another CNF vendor that it comes. So in the same way that basically you can do the Flux bootstrap with Flux, you can do the Silva bootstrap with Silva. You basically can start from your own laptop, where you have all you need to just start this entire process is you need to have Docker installed. You can run a small kind cluster, which is a small like Kubernetes distribution inside the Docker container. And you just kind of get away from having, like I've said earlier, a plethora of tools to deploy on basically, I don't know, depending on what your infrastructure is. So a bit before we go a bit deeper into what Silva is and what it does, these are just some slang terms because you might not know. I mean, bootstrap cluster and management cluster are kind of obvious what they could be. The workload cluster as well. The Silva unit, on the other hand, what we refer to it is as basically every piece of software that comes bundled and deployed by Silva. This can be either, I don't know, a storage, a CSI, or Grafana itself, or Longhorn, or whatever it is. You know, if it's in Silva, it's a Silva unit. That's easier for us. So what do we actually get? Because we've talked about handling the entire lifecycle management of Silva. So it's not just a way for you to deploy the cluster, but it's a way to upgrade it, to resize it, to, I don't know, change images in it, or actually change the type of Kubernetes clusters that you have altogether. So it comes back with what may seem a lot of things. There are actually even more than this, but I couldn't make the squares quite big to fit them all. But it tries to accommodate pretty much all your needs that you would have, starting from, I don't know, security part like keyvec, no-new vector, keycloak for single sign-on for all your web UIs. It tries to give you everything you need for observability, logging, monitoring, and everything like that. The lifecycle part is basically, you know, stuff related to the clusters themselves and the lifecycle management of those, and storage and networking, which hopefully in the future will be actually even more expanded to try to because the entire point is to be vendor agnostic, to not have you stuck with one vendor, not even for the operating systems, let's say. I mean, at this point, it's Ubuntu and SUSE. For the Kubernetes distribution, it's RKE2 from Rancher and SUSE, and kubeadm, and it's a work in progress for OKD, which is basically the free version of OpenShift, and canonical Kubernetes, if some people are not very aware maybe of that icon, what that is in there. So I've talked about needing just a machine with Docker and where you spin up a kind cluster, and then you need like a values file which we come back to the same old YAML, and you just need to put in some things based on your infrastructure provider. Here I went with an OpenStack provider because it was easier. For bare metal, I would have need to scroll down like 3 screens for you to see the entire thing. But actually it's very minimal for OpenStack. At least you just say it, okay, we want the infra provider to be Capo, which is the cluster API provider for OpenStack, the Bootstrap provider for the Kubernetes. You select what type of OS image you want. You want maybe an Ubuntu, you want it to be hardened, yes or no. Based on this, we will calculate in the background, okay, this is the latest image for Ubuntu that we have with the tag, is it hardened or not? If you select SUSE, it's basically the same thing that it happens. We want this many machine deployments for the workload clusters. You give it a storage class that you can consume from the OpenStack. And then you need, of course, would be a secrets file for the cluster itself, where you put the, how to connect to OpenStack basically, and your domain and your key. So once this is done, this is a small intro of what it actually happens when you run an apply ch. This is basically very, very similar to because we're trying to be GitOps. We're not quite there yet. We're working on moving a lot of these things to some operators, and so that we can decouple entirely from these pesky bash scripts that they are still making their way into production. But what it basically does, it just forces Flux to reconcile over that latest commit that you have, or what your branch or checkout it is. And the whole point of this was not to actually get something meaningful out of it, because it's just writing on a screen that goes very fast, but it's rather to see the extent of how many things are deployed in Silva. Yeah, basically we're not quite there yet with the GitOps part. Like I said, we're hoping to get there. We're hoping to integrate just as more CNI, CSIs, everything like that to be able to accommodate everyone and everyone's needs without, getting into the same problem that we have with getting vendor locked in any situation. That's, I think, the big view of Silva. In the end, this is what is going to hopefully be coming soon, maybe later for some of them, I don't know. So what we're trying to struggle here is the vendor agnosticism we're still using for the monitoring stack and the logging stack. It's not that they are necessarily from a vendor, but the charts themselves are from Cattle, so they're from SUSE right now, and we're trying to break away, and we use the ones from the upstream logging, so it's kube logging and everything like that. We're trying to modify and provide better usage for the Silva copy cluster, so that you don't have to depend on a certain branch of Silva to have the cluster API provider in Silva already. You can just do a clone on the Silva main, and you just plug and play your own cluster API provider that you need, that we haven't covered yet. And do the same with the Silva units, basically, to the extent this is kind of doable right now, but it's a more hackish way, and we're trying to do it in a proper way that if you have a piece of software that is maybe proprietary to you, or that you actually need it in your cluster when we don't have it, you want it deployed as a Silva unit to be in the same lifecycle management with Flux, then this should be in the same way extensible for you to be able to introduce everything that you need in there. And of course, the part with the GitOps all the way, we want to really push for those operators. And yeah, that pretty much concludes it, I think.
We still have 2 minutes to conclude. Yeah, sorry for this. Yeah. So not only these activities are relevant to us, we are involved also in such research activities. We are founder member of Etsy Software Development Group with some partners in Europe. As I've said, we are trying to bring up the European sovereignty with this effort. We are involved in research activities that are giving us ideas of telco cloud transformation and telco transformation through AI, machine learning, cloud native software solution or software-driven solution within these few projects. And what is relevant, if you need or if you want to deep dive for more details, you have there a link where you can find all our cloud native research security topics with involvement of AI and machine learning. Of course, we have this section for if you want to question if it is needed. So thank you from my side and from Mihai's side. Here we have the links. And not in the end, to conclude, please visit our stand for more cloud, let's say, experience. Thank you.